There we go. Welcome to week 6, Google Hangout 1. So we have another test this week, right?
Yeah.
Yay.
So what do you guys think of the written portion on the other tests?
It was hard, but
It was hard, but I feel like I did pretty well on it.
Yeah.
But
hopefully.
I missed one question on the multiple choice, so I got a 75%. That sucked.
The multiple choice was interesting because, like you said, if you missed one question, you're already starting at a 75, which is ridiculous.
Pretty big.
There's one question I tried to work out my calculator, and it wouldn't come out on any of the answers. I was like, well, all right, so I'll just guess, and I got it right. So
Wow. Nice.
Yeah, it was pretty dumb.
All right. Yeah, I don't know, guys. I did pretty good on the homework for this week, but for the preparation activity for this one, for the Google Hangout, I had no idea how to do the first. I got the first problem, and then the next one, I had no idea how to even start it.
The preparation?
Or no, sorry, the extension problems for the Google Hangout.
Oh, well, you guys want to do those now?
Sure.
What is this weird box? What does that mean?
What box?
Oh, that's just listing the problems that way. I don't know why, but
okay. Oh yeah.
The rules were pretty easy. The homework was really easy. I did most of the homework last night at 2 a.m. So
nice.
Logarithms are super easy once you get to know all the patterns.
Yeah.
I bought a new calculator so I can put logarithms in.
Dude, sweet. Okay, so yeah, do you guys just want to solve the first one and then we can talk about it?
Yeah.
Okay.
Yeah.
Oh man.
Wouldn't we
My dog pooped.
That sucks.
Yeah, that really sucks.
For log x minus 3, wouldn't we raise both sides to the 10th power just to get rid of that logarithm?
So you just
raise it to the 4th power.
Yeah, because 10 is just the base there, so you just raise it to the 4th.
4th power, okay.
Yeah. Okay, so did you guys get 10,003?
Yeah.
Let's see. So what did you get, Caleb?
Wait, so what power did you raise it both sides to?
Well, so you're just rearranging it, so it's just 10 to the 4th equals x minus 3. And then you add the 3 over to the other side.
Yeah, that's what I thought it was, but I thought you said you raised it to the 4th power, so all right, so I raised it to the 4th power. Or I raised it, yeah. I didn't put 10 to the fourth. I just put 4 to the fourth, and I just mix it up that way.
Okay, I got you.
Yeah. Previously, I
So
was doing it just like that, so I understand it.
you got 10,003.
Yeah. All right, guys, stop talking about Curtis. He's back. I'm just messing. Yeah, we got 10,003.
Yeah, I got it now.
Cool. So yeah, I got the first one good, and then I was like, all right, I got the second one. At least I thought I had the second one, and I got x equals 1/2, and then I checked, and it was like not even remotely close to the answer. So I have no idea how to solve the second one.
Okay, let's see. Is that the one below it or one to the right of it?
I just went to the right.
Okay. So let's see. Oh, how did that one work again?
Oh, I just realized you have to multiply the logs. I didn't do that. Maybe that'll change it. Let me see. Okay, I think
Which rule would you use on this?
okay, so I think what you do is, since all the bases are the same, you just do like 2 to the x times 2 to the x plus 2 equals 2 to the 6x plus 1. But I think what I did wrong and why it gave me a completely wrong answer was because I didn't multiply 2x by 2 to the, or 2 to the x by 2 to the x plus 2. Because if you multiply them, then it gives you like a parabola. And so then you have to use the, whatchamacallit formula, the, can't think of the name.
But wouldn't it not be 2 to the x, isn't it? Just for logarithms, it's 2 raised to whatever power equals x, or log base 2x. Right?
So I think that only applies when it's like equal to like a number or x, but since you have logs on both sides of the equations, I think that's why you can do that.
Okay.
So let me see what it comes out to be, because I might be wrong, but I think that's what we're supposed to do.
don't know. Isn't there a rule about multiplying logarithms?
I got it right. I figured it out. So if they all have the same base for the logarithms, you can just take those out. So it's x times x plus 2 equals 6x plus 1. You just solve it like a polynomial equation.
Okay, that's what I did, but on the other side, I multiplied 6x plus 1 by 2 because I thought, so when I multiplied 2 to the x by 2 to the x plus 2, I got 4 to the x squared plus 2x, but I didn't realize like you keep the bases the same, so that makes sense.
Yeah.
Okay.
So it's 2 plus or minus square root of 5, and then it wants you to get that in a decimal form.
Okay, cool. So that's actually a lot easier than we thought. Sweet. And so decimal form, yeah, 4.24?
Yeah.
Okay, cool. And then the next one.
So,
Yeah.
So you did the quadratic equation and you had 4 plus or minus 2 square root 5, right? Over 2.
Yeah, and then you just simplify it. It becomes 2 plus or minus square root of 5.
Okay, I see. Okay, cool. So, but there's no plus or minus because of the domain restrictions. So now you really have to check your work.
Yeah, that's stupid.
So what is it? Can there not be a logarithm for negative numbers? Is that what it is?
I don't know.
Let me see.
Yeah. Can't have a logarithm for a negative number. So number 3. Did you guys already start working on that one?
Yeah.
I feel like
I
think it's
so it'd be log. So
it would be like no solution or something. No, there's a solution. That's weird. Okay, I don't know how to do this one.
Hey, I got it right.
Did you?
Yeah.
How'd you do it?
Woohoo! So with on one side you've got log of x minus log of x minus 1, so that's log times x over x minus 1. Remember that rule? When you're subtracting logarithms,
yeah,
and they're the same base, then it's just a fraction.
Gotcha.
It'd be like log times x over x minus 1. And then to get rid of the log, just take 10 to the second. So 10 to the second equals x over x minus 1, which is 100. And then 100 times x minus 1, moving the denominator over to the other side, is 100x minus 100 equals x. 100x equals x plus 100. 99x equals 100. X equals 1.01.
Sweet. You're a genius, Curtis.
No. Just got lucky.
All right, so for the next one then, would we do, since it's adding, you could just do, or I guess they all have natural log anyway, so I guess you don't need to. But since subtracting would be just dividing them, when you're adding, you would multiply them? Is that right?
So you got x plus 3 times x minus 1 equals x squared.
Yeah.
Wait, sorry, say that again?
Can you do that, though? Can you just get rid of the natural log if they're all natural logs?
Yeah, because they're all the same base or whatever.
Yeah. And the base is E, right?
Yeah, I think something like that. So for that, you just got x squared equals x plus 3 times x minus 1. So x squared equals x squared
Plus 2x.
Plus 2x minus 3.
So it's simplified to x squared minus 3 equals 0, right? Then add the 3 over to the other side.
No, it should be 2x minus 3 equals 0. You got x squared equals x squared plus 2x minus 3.
Okay, so if you have a 2 in front of the ln x, then x has to be squared then?
Yeah, because that 2 is equal to the 2 that would be in the exponential spot.
Gotcha.
Wait, so you multiplied the other side?
Yeah.
You multiplied x plus 3 times x minus 1?
Mm-hmm.
So you guys got 3 halves or 1.5, whatever? Okay. Sweet.
Is that correct? Yep. Cool.
Wait, so you got 2x squared plus 2x plus 3 equals 0?
No, so I got no, because it's a positive x squared on the one side, so you got to minus it from the other side. So that completely takes away x squared.
Oh, so negative 2x minus 3 equals 0?
It should be a plus 2x minus 3.
Oh, yeah.
So you got 2x minus 3 equals 0. Bring the 3 to the other side. 1.5 equals x.
Okay.
You still with us, Julia? Or you fall asleep?
No, I'm kind of lost because the first one, the second one, I'm sorry, the second one where it says like log 2x times log 2x plus 2, we multiplied it. Like we just like dropped the log and kept everything the same. But now in this one you're saying that, in this one you're saying that you drop the logs, but you multiply them instead of adding, which is.
Yeah, so he just simplified it. So like he just made it less steps, because if you keep working it out, like if you take each of them and you take e raised to whatever is in parentheses, then they'll just cancel out later on anyway, which is what we did in like one of the earlier problems. So it was just more steps before. But
I think Julie is confused because one of them said log times log, and we multiplied it, but the other one said log, natural log plus natural log, and we still multiplied it.
Yeah, I was just thinking about that too.
Okay.
But we know that
I don't know.
there's the rule, one of the rules of the logarithms is that if you're adding logarithms, then that's like multiple or something.
Yeah. Yeah, so if you add a logarithm, that's equal to, so like I said, the log of x plus 3 plus natural log of x minus 1 is equal to x plus 3 times x minus 1. But then for the one where you multiplied, that rule is like, it's like x to the a in parentheses, and then raise that to the b power. That's also equal to x raised to the a times b power. But there's no like power here, so it's like,
Right.
I don't know how that worked.
We got them right, though.
Yeah.
You still need some help, Julia?
Yeah, but I'll figure it out later. It's just like I think it's just I am getting a little confused about the inverse and everything, where you use the e and don't know exactly where to put it.
Yeah.
But I'll figure it out.
Maybe it has something to do with the fact that one's a natural log and the other is just log.
Yeah.
So
Well, if you have natural log x plus 3 plus natural log x minus 1, that's saying natural log of x times x plus 3 times x minus 1. It's the same thing. So you could, even before you did anything else, you could condense that. So the problem would be 2 times natural log of x equals natural log of x plus 3 times x minus 1. Instead of natural log of x plus 3 plus natural log of x minus 1. You can put that in the same, because they're the same base, you can put the same natural log. And then, like we did, we got rid of the natural log because those are going to get canceled out later anyways.
Yeah.
The one I'm confused about is the second one, but we got the answer right, so.
Yeah. I don't understand it. I just know we got it right, so I feel good about it.
Mm-hmm.
So I guess, I don't know. I'm sure there'll be problems like, I think there's problems like that in the homework. So you can go through kind of the give me example
Yeah.
stuff, and I'll kind of explain things a little better. That's how I learned it all last night, is just by doing the homework. Because I don't ever get anything out of the reading. They use big words.
Yep.
So. All right, we ready to go to the last one on there?
let's do it.
1.02. So that.
So I got the right answer, but I got negative 20.57.
Huh.
Because, so I set it up as log with a base of 1.02 and then parentheses 5 equals, but I got negative 4x minus 1, and then you add the 1 over, but then that leaves you, that equals it to negative 4x, so once you divide by negative 4, that's what I'm confused about.
Yeah, I got 20.57 as well.
I'm going to plug in the answer that she gave us and see if it even works out, because maybe it's an error. Let's see. Yeah, so I think she gave us the wrong answer because plugging in, or no, sorry, hang on. No, yeah, she gave us the wrong answer because it's supposed to be negative. Otherwise you get like 0.19 or something.
Yeah, so you guys got negative 20.57.
Yep.
Funky business.
Yeah, and that gives us 5. But if we plug in the answer that she gives us, the original problem, it gives us like 0.19 or something. So she probably just wrote it down wrong.
Okay. Cool.
Is that fantasy?
What's
What?
What was that?
Someone's phone went off and they sounded like it was fantasy because mine does the same thing whenever I get like a fantasy update or whatever.
Oh, that was my ESPN app.
Yeah, fantasy football.
Yeah, my fantasy team is doing not good.
Nice. All right, so number 2. I get for the test, is she gonna have us like memorize these formulas? Do you guys think?
Let me see if I can remember what it is. So it's like A equals.
Shoot. I deleted my fantasy football app. I don't know how. But I'm undefeated 6 weeks in a row.
Nice.
Oh no.
Okay. Sorry. So now we're on question 2.
So isn't the
Yeah.
formula for interest, isn't it A equals P times 1 plus R over N
To the
is
end.
the NT?
Yeah.
Yeah.
Okay.
And then for N, since it's compounded quarterly, you'd put 4.
4. Yeah.
Yeah.
So you got 5,000 times 1 plus 0.056 over 4 raised to the 40th.
Cool. Compounded continuously. Have that formula written down.
Yeah, what does continuously mean? Like, is it like every day or what?
There isn't a like compounding period. It's more than every day. It's more than every minute even. It's just like I don't know how it works, but
So for the first part, I got $8,719.43.
yep.
This one you got 4,000 equals 400 times 1 plus 2 over 4 T. So if I split both sides by 400, get 10 equals 1 plus 0, 2,
Wait, what?
4. So for this one, you're supposed to find out what T is.
Oh, did you get the second part of number 2?
Oh, I didn't do that part. I didn't see that. Sorry, guys.
No worries.
So did you find the formula, Curtis? Like what you would put in for N?
Formula for continuous is A equals P times E to the RT. So E to the RT times P equals A. It's like this.
Okay, cool. Did you guys get $8,753.36?
Yes.
Sweet.
8753.36.
Yep.
Okay.
All right. Did you get that, Julia?
Yep.
Cool. So you guys want to move on to the second part of of 2?
Yeah.
Invested $400. Okay. So this one we just plug back into the formula, just like the homework.
So we're on the next one.
Yeah.
So this one,
I divide by 400 first, right?
yeah.
Yeah, so you're solving for T. So
So
you
you got
get
1 or T plus 0.02 over 4 to the 4T. 10. Do this one.
So here you would do log to the base of
So you got log base 1.005, 10 over 4 equals T.
yes. Wait, over 4?
Yeah, divided by 4.
How did you do that?
So you got, I divided all by 400. I got 10 equals
1
1 plus 0.02 over 4 raised to the 4T. And you just kind of simplify that inside part. So it becomes 1.005 raised to the 4T. Plus
Okay.
log base 1.005, 10 equals 4T. And then divide all that by 4. So I got 115.42.
So I got like all the work right, but like I didn't divide by 4 because I'm still not sure where that came. So like the answer that I got was 461.67, which is 4 times what the answer is. So like I'm just trying to figure out where, like why you divide by 4.
Because your exponent,
Uh-huh.
it's n times t. So the n number of times is 4, and we don't know what t is.
Gotcha.
So,
I totally left out the 4 time. I didn't put the 4 on the top. Okay.
no worries. I just checked it, and it's right. So It's 115.42 years.
So you had log, base. Okay, log little 1.005, and then 10 over 4.
Yep. Yep. All divided by 4.
Shoot. Well, I have that part, but my calculator, you can't change the base of the log or whatever.
Oh. So if you can't change the base of the log, if it's just like regular log, just do log 10 divided by log 1.005.
Yeah. Oh, I see what I did wrong.
And then divide all that by 4. But
There we go. This is fun.
yeah.
Told you it was gonna be fun.
I love math.
It's fun, but I'm still good not being a math major. So, this next one, 18 equals 6 times e to the 5t.
So 3 equals e
To 0.05 t.
t.
Yeah, so that's my bad, 0.05t. How do we get rid of the e again? Do you just take it all to the natural log, or?
No, so it'd be ln 3 equals 0.05 t. So you would e is the base, and then 3 is what would be in parentheses.
Gotcha. Please take natural log 3 divided by 0.05. We got 21.97.
Yes. Did you get that, Julia?
Yep.
51.97 years.
Oh boy.
Eesh. So 40, let's see. Got 2 million equals 4,400. 1 plus r over 1 times 200, or raise to 200.
Yeah.
This one doesn't look as fun.
Oh, there we go. Okay. You guys figure it out?
No.
Okay, so 2 million divided by 4,400 first.
Yeah. It's 454, 54, 54, 54, 5.
Yeah, so just do 454.55 equals 1 plus r to the 200. Yeah?
Yep.
And then you just keep 1 plus r in parentheses. And you take 454.55 to the 1 over 200.
Wait, say that. 2 to the what?
So you take 454.55 to get rid of the exponent. You take 454.55 to the opposite of 200, 1 over 200.
Okay.
Because if you have an exponential or a fractional exponent, then to swap it to the other side, you just flip it over. So if you have 200 over 1 on one side, you can flip it over.
Okay.
So you get
That
the
just equals
200th root of 454 minus 1 equals r.
So you got 3.1%.
Yep.
Sweet. I don't like that one.
As a team,
yeah, right if we get done talking about how fun this is.
let's discuss the
Slap in
different
the face.
methods that you could use to solve the following equation. There are at least 4 different ways to solve this equation. No matter which method you use, you have to solve using a logarithmic function. Possible options are using a log base 3 on both sides, a log base 5 on both sides, a log base 10 on both sides. Or a natural log on both sides. What benefits do you see for each of the following cases? The following guided practice shows the log base 3 option and the natural log option. It does not matter which method you use. So what's the function?
Yeah.
Oh, a 3 to the 2x minus 1 equals 5 to the x.
Yeah.
Okay, so it's saying you could, okay. Um, okay, and then you bring it over to the other side, I guess? Or what the?
Which one are you doing?
I'm doing the left side, applying the log base 3 to both sides.
How did they get that?
So I think they divided log 3 parentheses 3 to the 2x minus 1 by log 3 parentheses 5 to the x, because that would give you 1 on the other side. But I don't get, how they simplified those.
Wait, what? You said log 3 times 2x minus 1 over 5 to the x?
Over log 3, 5 to the x. Because if you have log 3, 5 to the x on both sides, and you divide one side by it, then it'll give you 1 on the other side. If you just divide it by itself.
Okay, what you could do is 2x minus 1 times the log 3 of 3 equals x times the log of 5.
Oh. I think I'm starting to get it.
If you do the log 3 of both sides, doesn't it simplify? You can do 2x minus 1 equals the log of 5 to the x.
I'm not sure.
Remember when we first started doing these, we did something like that. Yeah. So you take the log 3 of each side, right? Then you have log 3 times 3 to the 2x minus 1 equals log 3 times 5 to the x. But when you have like that 3-layered 3 to the 3 to the 2x minus 1, you know?
Yeah. It puts that out in front.
You could just get rid of that, and you're just left with 2x minus 1 equals log 3 of 5 to the x.
How do you get rid of it on the other side? Is it just because it's a...
It's just the rules, I guess. It's the rule. I have it here.
Because I'm just trying to understand why you cross it out on one side but not the other.
I think it's because, like, you're doing 3 log 3, that, like, 3's end up canceling each other out. It's like 10 log 10, which is equal to, like, 1. Or
Okay.
Gotcha.
Yeah.
So yeah, you got 2x minus 1 equals log. You just put 1 to the other side. You bring the log 5 over, right? And you put 1 to the other side. You have x on the same side, and then the.
And you bring the x of the 5x, 5 to the x. You can bring that out front. So 2x minus 1 equals x times the log of log 3 of 5. And then you can take the 1 over to one side and the x to the other side.
Factor out the x. So you get x by this log 3, 5 equals 1. You divide that and just get x on its own. And then you can put that into your calculator. And then it comes up with 1.8.
So log base 3, 1 divided by log base 3, 5.
Next.
So you factored out the
Yeah. You factor x equals. So you have. So what you ended up getting to get x all the time. It's 2x minus x log 3/5 equals 1. So since you have x in both, you can factor out the x, and you get x by 2 minus log 3/5 equals 1. So then you can find what's in the parentheses, and you get x all by itself equals 1 over 2 minus log 3/5. And then you put that in your calculator and get 1.8.
I see. Kind of. It's weird. It's really weird.
Yeah.
Huh. Interesting.
I don't get it. I don't get how you did that.
It's got it in the answer key. Kind of shows you how
Yeah,
she did it.
you see that?
Just got to go back to factoring. Makes sense.
Oh, okay. Still doing construction in your house, Colin?
Yep. I don't think it'll ever end. So how do we do these half-life problems again?
There's a half-life formula, I think.
Yeah, I don't remember what it is though.
It's A, which is stands for the final amount, equals A0 or A subscript 0, which is just like the initial amount, times parentheses 1/2 raised to the T over H, and H stands for half-life, T is the amount of time.
What is the H? Like the rate?
It's the half-life. So like for this problem, the half-life is 5,730.
Gotcha. So we do.
So 3.4 equals 0.1 times 1/2 T over 5,730.
Mm-hmm.
Oh, I thought you'd switch the 0.1 and the 3.4.
Yeah.
So it's 0.1 equals 3.4 times 1/2 raised to the T over H, right?
Yes.
Sorry.
Okay. You're good. Just want to clarify it. So we have log.
So just a heads up too, like I rounded when I divided 0.1 by 3.4, but you can't round, like you have to go like super far out. Otherwise it'll give you a different answer.
Okay.
You'll be off by like 100 years. So just a heads up.
So log 1/2. No.
Yeah, log base 1/2.
Yeah.
0.02941117.
Yep.
647.
Equals T over
5730, right?
5,730.
Yeah.
Yeah.
Just multiply the log stuff by that.
Yep. And then you should get 29,151.16 years.
$29,151.16. Yep.
Sweet. Did you get that, Curtis and Julia?
Yes,
Sweet.
I did. Did you, Julia?
Yeah.
Dope.
Awesome. So last problem, 15 grams of radioactive waste.
You just multiply this one by 1 over 1,000.
Yeah.
What?
I got 584.96.
So it should be 1,709.51.
That's not cool.
So let's see, let's go through it. So what you do, plug it all in, and then you get basically to the same steps as like last time, but instead of multiplying the log by the half-life, since we don't have the half-life, you have to multiply the log by h and then divide 1,000 by the log to solve for h. Okay. Oh yeah, just something that I figured out, guys. If you do, when you're doing logs, like maybe it's easier for you, it's easier for me, but say you have like log 0.6667, and the base is 1/2, it's the same thing as saying like natural log 0.6667 divided by natural log 0.5. It's like you can always divide whatever's in the parentheses, like take the natural log of that and divide it by the natural log of the base, and it'll always give you the same answer. So that's just easier for me to plug it in the calculator.
Okay, thanks.
Yeah, no problem. So everyone get 1,709.51 years?
Yes.
Yep.
Cool.
Okay, cool. So we have another exam this week.
Yeah, we
Right.
do.
Fun.
So those word problems actually seem like pretty straightforward. So I'm probably just going to focus on studying like the log rules again, since like I'm a little confused on those when I study for the test, because it seems like that's what tripped us up the most.
Yeah.
All right, cool. Well,
Anything else you guys want to go over? You guys good?
Hopefully.
I'm good.
Okay.
All right. Sounds good.
So who's turning in the link?
Callum,
So I turn in the link, and then, yeah.
and if there's a group quiz, then I'll turn it in.
Sounds good.
I'll send you the link.
Sounds great.
See ya.
See you guys.
See y'all.
All right.